Hello students, welcome to the Electrical Engineering YouTube channel. In this lecture, I am going to discuss the comparison between two types of synchronous motors. First type is called salient pole rotor type synchronous machine and the second type is called cylindrical rotor type synchronous machine. The salient pole rotor has such a design. So we have these salient poles and there are windings over these cylindrical bars and these windings are excited using a DC supply voltage so that a magnetic field is produced. That magnetic field actually interacts with the magnetic field of the stator, which is actually revolving magnetic field, and due to this interaction or due to this attraction, the synchronous motor works. The other type of synchronous motor has cylindrical shaped rotor, which we can observe in this diagram. So this is a cylindrical rotor and there are slots at the outer periphery, and these slots actually contains the windings to produce the magnetic field in the rotor. And again, this magnetic field of the rotor interacts with the stator magnetic field, and the synchronous motor works due to this attraction between the rotor magnetic field and the stator magnetic field. Now, the design of these two rotors is clearly different. This is a cylindrical rotor and its cross section is actually circular. So, such a rotor is useful for operating at high speeds, and this type of rotor is actually useful for producing high torque but small speed applications. When such a motor is run at high speed levels, it actually oscillates because outside this rotor surface there is a stator, and this rotor is actually packed in the stator core. So when this motor runs, there are actually non-uniform air pockets between the stator surface and the rotor surface, because these salient poles actually produce a non-uniform air pockets, and when such a motor is run at high speed, vibration in the motor and oscillations produced, and this also produces a noise whenever such a motor is running at high speed. So such a motor is useful for running at low speed and high torque applications, and this paradoxically, this type of rotor is actually uniform and there are no non-uniform pockets between the rotor and the stator, and the air gap between the rotor and the stator surface is uniform. So whenever such a motor is running even at higher speeds, it will be a silent operation, noise-free operation. There will be no mechanical vibrations and oscillations when such a motor runs. So this is the basic difference between these two types of the synchronous machines. And a salient pole rotor actually is useful for low speed applications. So these are low speed electrical machines and their speed varies from 100 to 1500 RPM. The cylindrical rotor type synchronous machine are high speed electrical machines and they can be run at 1500 RPM to 3000 RPM. And in salient pole rotor, there are more number of poles, and since we have to keep the speed small, so more number of poles are designed to keep the speed small. So synchronous speed is small when we have large number of poles. So poles actually vary from 4 to 60. Up to 60 number of poles can be designed for salient pole synchronous machine. But in cylindrical rotor type synchronous machine, number of poles can be either 2 or 4. And flux distribution is sinusoidal in cylindrical rotor type synchronous machine. Here flux distribution is poor, it is not actually sinusoidal, and there will be harmonics in the obtained voltage if we are running this machine as a generator. So when these machines are running as generator, this will produce sinusoidal EMF and it will produce non-sinusoidal or distorted sinusoidal EMF. And a synchronous machine, a salient pole rotor type synchronous machine needs a damper winding to reduce the oscillations, and in cylindrical rotor type synchronous machine, no damper windings are required. So another difference is that these synchronous machines are used in hydropower plants And cylindrical rotor type synchronous machines are used in nuclear gas and thermal power plants. Since these are high speed machines, so high speed generators actually are nuclear power plants, gas, and thermal power plants. But in hydropower plants, small speed is only available, so this is useful for running the salient pole rotor type synchronous machine. Now, the next thing is the damper winding. So why we need damper winding in synchronous machines? So whenever a salient pole rotor type synchronous machine is excited by a three-phase supply, revolving magnetic field will be set up in the stator, and that magnetic field will be linked with the rotor. Now the rotor should be running at the synchronous speed, but at start this rotor will not be able to lock its magnetic field with the magnetic field of the stator. So these are the pole shoes, and these pole shoes contain number of slots, and damper windings are actually present in these slots at the pole shoes. So these damper windings actually tend to run the synchronous machine just like a induction motor. So in induction motor, whenever revolving magnetic field interacts with the rotor, EMF will be induced in the rotor windings, and the motor experiences a starting torque, and gradually it starts revolving, and after some time the motor reaches the steady state. But in synchronous machine there is nothing mechanism to produce the starting torque, so that starting torque is actually produced by running the motor as induction motor, and due to these damper windings, slight EMF will be induced in these damper windings, and the current will be produced, and according to the phenomena of electromagnetic induction, the motor will experience a starting torque, and when the motor gains the maximum speed, uh, the magnetic field of the rotor will be locked with the stator magnetic field, and the motor will start running as a synchronous motor. So the rotor will be synchronized with the stator magnetic field. And when we change the load of the synchronous machine, suddenly the speed of the rotor will be reduced, and there will be severe oscillations in the synchronous machine. Again, when there is oscillations, there will be slip produced in the rotor, and when there is a slip, again these damper windings will start playing their role, and slight EMF will be induced in these damper windings, and due to that EMF they will shift the torque, and they will reduce the oscillations due to the disturbance, either any disturbance or due to the change of the load in the rotor. So these damper windings are very useful. They are used to start the synchronous machine from rest, or they are used to produce the starting torque in the synchronous machine, and they are used to reduce the oscillation whenever a disturbance is produced or whenever a load changes across the synchronous machine. So at start, EMF is induced in the damper windings to rotate the rotor as in the induction motors. At running condition, synchronous speed is equal to the rotor speed, so no EMF is induced in the damper winding, so they are virtually isolated from the machine. When a load changes suddenly, vibration starts, which cause the rotor to oscillate before settling to the final value. So when these oscillations come into play, again damper windings will have induced EMF in them, and they will try to reduce the oscillation, and they will also reduce the settling time with the use of the damper winding. So that is all about our today's lecture. For watching more similar videos, please stay tuned to this YouTube channel. Until the next lecture, it's goodbye.